So welcome everybody to Cloud Native New York, our is it October 6th edition. So Gabby and I are very, very excited for today's topic. We have Greg Rivera here. He is Vice President of Software Intelligence at CAST, and he's going to tell us how to enable your teams to migrate to the cloud faster and more safely. And it's really exciting. We've had a little bit of chat with him just leading up to starting this recording. So we are both very, very excited for this topic. It's a lot of really good stuff. And so I'll turn it over to you, Greg, right away. The hour is yours.
Very good. And I don't think we'll need to take a full hour, but let's go ahead and dive in. So Cora, thank you. Gabby, thank you for having us here today. We're also very excited to be speaking to this kind of audience. So before I dive in, I actually have a fun video that I'm going to play, and I think this should work if I'm sharing it. So please let me know if it's not, but I'm going to kick it off with this before we dive into the content today.
Uh-oh. This concerns me.
This is our pride and joy. Our most critical custom-built software applications over the company's entire history, all working together in harmony. Here's our operations management software built in 1986, last upgraded in 2003. Here's our entire trading platform, still running on OS 390.
What are you going to do with this?
We're sending this baby up to the cloud.
Do you even know what's inside? How it works?
I feel blindly optimistic that this will not ruin the company.
Just use CAST.
Huh?
It's like an MRI, but for software. It actually reverse engineers the software system architecture and shows you
interactive application maps showing end-to-end transactions and data access paths. I could see inside.
Which will help our architects and developers navigate to the cloud.
CAST. Know what's inside your software before sending it up there.
Okay.
So cool.
Hopefully that came through all right. You know, obviously we're having fun there with that video, but the reality is a lot of us.
So, ladies and gentlemen, it's my great pleasure to welcome Joe Justice, our keynote speaker.
YouTube
for the
is
second day
playing
of
their
our
next
conference.
video in the background. Sorry about that. So sorry, what I was saying is that obviously we're having some fun with that video, but the reality is I think many of us have actually seen scenarios like that in real life on a regular basis. It's not that far fetched from what we're seeing out there. So basically that kind of sets the stage nicely for a discussion on how CAST is helping businesses and organizations use software intelligence to empower their teams and enable them to get their custom software to the cloud faster and safer. So what we'll go through today was very quickly just talk about the challenge that's out there. It's not going to be a surprise to folks, but then we'll start talking about why this concept of software intelligence is important, how it works, and we'll do a quick demonstration of a few of the software intelligence type insights you can get to help empower faster and safer migration to the cloud. And we'll have plenty of time for Q&A at the end as well. But first off, you know, this is not going to be earth-shattering news to anyone, right? We know cloud migration is challenging. It's a massive global initiative. In fact, according to IDC, they are estimating there's over 500 million applications currently slated for migration to the cloud or modernization. So it's a massive, massive opportunity globally. The challenge is that there's not enough skills specifically to help modernize applications to take advantage of cloud native. We're not talking about creating new applications, cloud native. We're talking about taking legacy or existing on-premise applications, big, massive enterprise software systems, custom software, and modernizing them to be cloud native. There's a shortage of skills for that. It's delaying migration projects by multiple years. We know that a lot of the easier stuff has already been moved, right? Using that more lift and shift approach. Where there's not a lot of changes happening or modernization happening to the software as it's moving to the cloud. But studies are showing that the success rate of the lift and shift is less than 40% because sometimes it's actually potentially using too many resources, costing more because there hasn't been any modernization of the software and things of that nature. So the reason this is happening is one of the pitfalls is not analyzing your applications before migration. Now, a lot of companies and enterprises and organizations are very good at analyzing the infrastructure that they need to move up to the cloud, but we're not always seeing organizations take the time to truly analyze their software, the inside of their applications before migration. And that's driving a lot of these challenges here. So the question is, why is this so hard? Well, in theory, applications, particularly big custom enterprise software systems, look like this. We have very good disciplined engineering, software engineering, coding practices. They're neatly organized in boxes with different tiers, good documentation, etc. The reality, for those of us that have seen enterprise software systems, is they look a lot more like this picture on the right. This picture is actually a zoomed out image from one of our products called Cast Imaging that basically automatically reverse engineers the entire architecture of a software system graphically. And it's not even that big of a software system here. We're talking about a few 10,000 lines of code. Multiple technologies, multiple tiers, a spider web of interconnectivity. Changing something in the bottom right of this picture could impact things in various other places in the upper left of the system. So this is not that easy. It's hard. There's a reason why this is a hard thing to do. Software has become extremely complex and highly interconnected with multiple technologies and tiers and things. So that's where we come into play. Some companies are taking an approach that they call software intelligence. And essentially what software intelligence is it's using technology to automatically analyze the inside of custom software by analyzing the source code of that software. And that's used for various purposes to make decisions about software assets. It's used to help decide how to modernize systems, how best to migrate software to the cloud. It's used to help manage risk, to rationalize application portfolios if you have lots of applications and things of that nature. So there's a number of use cases. Today, we're going to focus on the use case of how software intelligence is helping organizations get their custom software up to be cloud native faster and safer. So let's dive deep very quickly, and then we'll come back up and show a very simple, specific example of trying to attempt a cloud migration without software intelligence, and then what it brings to the table. So very, very simple example here. We're really bringing this down to a very simple terms. Is an application owner or a technology leader might ask, why is my application not yet planned for migrating to the cloud? And the answer they get is, well, it's not cloud ready. It's not ready to go to the cloud or be cloud native. Okay, so then the next question that they would ask is, well, why is it not yet cloud ready? And the answer that you might be able to get out of the teams is, well, it has some blockers in the source code that are going to prevent it from going cloud native, right? This is the kind of information that you can probably get from teams without having software intelligence. But then if you ask that next level question, why are these blockers preventing the migration? This is where it's challenging to answer that question if you don't have software intelligence, because as we said, there's not enough skilled resources to go around that could answer these questions across all the companies and all the applications that are trying to be modernized and migrated to the cloud. So if you have software intelligence, you have a piece of technology that could actually help empower teams to answer this question if they don't have the resources or skills to do that. So when you ask that question, why are these blockers preventing migration? Well, here's a very specific example. Well, the application happens to be using persistent files and COM components, which are not compatible in a platform as a service or cloud native environment, right? This is a very specific but simple example that shows you why having software intelligence helps you identify and plan a cloud migration and estimate how to best make that move versus not having that additional intelligence. Okay, so there's different types of software intelligence. We just talked about cloud readiness with that very simple specific example, but what we're talking about there are code patterns in the source code of an application that make migrating software to the cloud difficult or impossible. We just gave a couple examples of using persistent files, for example. There's other types of insights that are useful when making a planning migration to the cloud. Software composition is another type of software intelligence insights. Software composition is analyzing the code and identifying the third-party components or dependencies or open source dependencies that could potentially introduce additional risks such as security vulnerabilities or licensing legal requirements and risks. So that's another area that goes into planning when going to the cloud. And then finally, software health, or insights like resiliency and agility. These are essentially coding practices in the code of the application that could make an application more prone to production issues or make software harder to maintain, right? All of these insights will actually go into how software intelligence helps make cloud migration faster, safer, and we'll see a demonstration of that in a few moments. Okay, so I'm with CAST. My role at CAST as head of software intelligence is I lead one of our products called CAST Highlight, which provides these types of software intelligence insights. And this is a technology that will automatically analyze the source code of applications and generate these different types of insights. So we already talked about cloud readiness using persistent files. That's an example of a cloud readiness insight. We talked about open source safety or software composition. An example of that is identifying, for example, that an application is using a specific library, such as this Gradle component, and that might have a critical vulnerability as part of it. That's a second type of insight. And then a third one is when we talk about software health, we're looking for coding practices that could result in an application having production issues or being more complex or harder to maintain. So here's an example of a pattern that might pop up in the software health area: avoid repetitive access to nested members. And there's hundreds and hundreds and hundreds of these different patterns that we look at across all different types of technologies. So those are just quick examples of the different types of insights that come out of software intelligence generated by our CAST Highlight technology. Okay, so now let's think about this in the context of migrating to the cloud. We often get asked, well, where does CAST kind of fit into the landscape? There's all these different products out there and technologies that help you plan or analyze or assess for cloud readiness or migration. Well, there's really three areas where our products are used. First, CAST Highlight's used in that initial portfolio analysis to help do that 5 R's assessment, or however many R's you're using. There's a number of different methodologies, but to essentially segment and prioritize applications will show that. You're also going to be doing infrastructure assessment at that same time. We don't do that. We are very complementary to other technologies out there that do infrastructure assessment, and there are many of them. Once you've started to segment and identify how you want to move applications to the cloud, for those apps that you want to become cloud native, you're probably going to need to either refactor or re-architect them. CAST Highlight will also be used again to start identifying what are the specific blockers in the code, what recommendations are there to remediate those blockers, what are the cloud native services that you could be using once you do get the application up to the cloud. That's a second area where CAST Highlight is used. And then we have another product called CAST Imaging at CAST that I showed that image a few moments ago. This is a product that goes very deep on a single application and reverse engineers the entire architecture and structure of a system and creates basically a graphical map, if you will, that you can navigate up and down multiple levels. Don't think of it like the Google Maps for a complex software system, right? This is often used when figuring out exactly how to refactor, re-architect a complex software system. So that's kind of where the CAST technologies fit into the overall landscape. So what we're going to show in a quick demonstration is we're going to first show how we analyze at the portfolio level a group of applications and start to segment and prioritize them into different migration categories. Then we'll drill into a specific application and show how you can use software intelligence to detect the blockers in the code that would prevent a migration, estimate the effort to remediate them. And then we'll also show how you could use software intelligence to identify what are the cloud native services that you might want to consider using once the application is migrated up to the cloud and in a cloud native state. We're also going to touch on, which isn't shown here, that software composition or open source risk area, which also comes into play when planning for a cloud migration. All right, so let's go ahead and switch over to demonstration here. I want to go full screen. There we go. Okay, so what I'm logging into right now is the CAST Highlight user interface. Again, this is a software intelligence technology. It's a SaaS-based product that basically generates all these insights by analyzing the source code of an application. And then there's another input. We have a few surveys built into the product for capturing some more qualitative information about applications. For example, the business impact of an application to help prioritize how important the application is to a business or an organization. So those are the two inputs. We're analyzing source code and we're capturing some qualitative information via surveys. Once those two inputs are generated and the results are uploaded to our SaaS portal, all the dashboards you see here are lit up and become available. Now, one important thing to keep in mind, when it comes to analyzing source code, all the analysis happens in the organization's environment on the premise. The source code never leaves the premise. You don't need to upload any source code. You basically are running an analyzer locally, plugged into the source code repository or just pointed at the location of the source code. It runs, and then it produces a results file, which is just statistics, the results of the analysis. And that results file is just a flat text file. You can open up and look at it. That's the only thing that gets uploaded to this portal, in addition to filling out some survey questions. So the source code analysis all happens locally. We don't need access to source code to generate any of these insights. Just wanted to mention that because that's an important aspect of how the technology works. But once you do that, and it takes a few minutes per application, and you can automate that and run them in parallel, you now have a number of different dashboards you can browse. So in this example, we're going to browse through a portfolio of applications made up of 212 applications. As you can see here, we have those different categories of software intelligence that I mentioned during the setup: the software health, the cloud readiness, the open source safety. We have some quick portfolio insights, but we're going to focus on this cloud ready area for purposes of the demonstration. Now, to explain this a little bit further, cloud ready basically is a score on a scale of 0 to 100. And the way we calculate this score is we're analyzing the source code, looking for those blockers that I briefly mentioned, also looking for good things. We have these things we call boosters that actually increase the score, right? And then once we do that, we basically calculate a score. The way to think about this score on a scale, again, of 0 to 100 is the higher the score, the more ready an application is to be deployed as a cloud native application or to be deployed in a platform as a service environment. That's the way to think of the score. The higher the score, the more cloud native, if you will, an application appears based on the coding and the software engineering of the application. So if we click on this, we're going to start at one dashboard that's at the portfolio level. So we're looking at all 200 plus applications. And this is called the Portfolio Advisor for Cloud. This dashboard is used by our users to start to plan out a migration of a portfolio of applications and to start segmenting them into different categories. Here we have a version of the 5 R's you may have heard of, where the product has automatically segmented and is recommending which applications in the portfolio should be rehosted, refactored, re-architected, rebuilt, retired, etc. Here we have our distribution, and we call this our Parliament chart. And then here we have every application represented by a bubble with a couple of metrics. So we have like the health of the application on the vertical axis, and then we have the cloud readiness on the horizontal axis. So we're representing the portfolio in a few different ways. If you want to see the full list of applications, they appear down here, and we list each application with some additional metrics. Now, just because Cast Highlights automatically recommending that a given application, for example, should be refactored, you have the option to change that manually because you may know something about the application that is something that we can't determine automatically through a source code analysis. So you could manually change that recommendation and save it. So let's take a look a little bit deeper about how this works. So for example, we look at one of these segments, the re-architect segment, right? So re-architect means you're doing much more than just some simple refactoring changes, but you're not rebuilding the entire application from the ground up. It's somewhere in the middle, right? So you're going to do some pretty significant change to the code of the application. So I'm going to drill into that segment, and we have our apps here. I'm going to turn on the names, and I'm going to hover over one here. There's an application I like to show here called Closure. This is a great example. So in the upper right there, you'll see some stats, lines of code, how big is the application, things of that nature. But I'm going to start at the bottom on these colored tiles. 74 roadblocks. right? That's a count of the individual number of issues in the code that could prevent or hinder migration. Then Cloud Ready, we see the score is 60.91. That's actually a pretty good score. So you might think by just looking at those first two elements that this is maybe a good refactoring candidate. It doesn't have a lot of issues. There's only 74 of them, and the score is pretty good. But then if we continue going up, you see some of these other scores that are more on the software health area, things like elegance, agility, resiliency. These are
All
measurements
I do
of,
is eat steaks. I walk into the restaurants and give me
these
your
are
most expensive.
measurements of how, oh, someone just,
And you know what's most
yeah.
annoying? And they start talking about options. Okay, well, we have the tomahawk or the ribeye.
Thank you. All right, so let me get back over there. So basically, the resiliency, agility, and elegance scores are essentially identifying how likely is this application to have production issues, how hard is it to maintain, how complex is it. As you can see, those scores in red, they're relatively low. Again, they're all on a scale of 0 to 100. That means this is an unhealthy application. So because of that, instead of simply refactoring it for the cloud, Cast highlights recommending that it also be re-architected to kind of improve some of the resiliency and complexity issues that this software application has. And that's why it actually ended up in the re-architect bucket versus in the refactoring bucket. That's just a simple example of how the model works, how the calculations are working. The calculations are completely transparent. You can customize them. You can create your own segments and formulas and weights, etc. This is just an out-of-the-box model that comes with the technology. So let's look at one application a little bit more carefully. So I'm going to pick one here, one I like to use called Experiences. And that'll be this application down here. In fact, if I click on this little target icon here, it brings up basically a calculation, a little grid that shows you how it was recommended to be a refactor candidate. And it'll show you the kind of the scores it got for the other segments, but refactor had the highest score. So that's why we're recommending that. If I click on that, I'm now going to leave the portfolio level of the 200 plus applications, and I'm going to go down and look at this one single application. So now I've already done my portfolio analysis. I've segmented my portfolio. Now I want to look at this one application that we've identified as a refactor candidate. I'm going to start at the overview here. So we have a lot of those same metrics that you saw at the portfolio level for this individual application. And there's a lot of different things going on here with each of these tabs. I'm just going to focus on a couple of them. First, software composition. I touched very briefly earlier on the concept of open source risks and the software composition based on the third party or open source libraries being used in software. That's built into the technology here. So what the technology is doing is it's looking through the code base and identifying all the dependencies, all the third-party open source dependencies that are being used as part of this application, and then identifying based on the versions of those libraries and components being used, are there any security vulnerabilities? So in this case, we found 145 components, third-party components being used in this application that have 8 critical, 23 high, 14 medium, 1 low severity security vulnerabilities. Also, just because you're using open source components, which technically are free, that doesn't mean they don't come with any strings attached. The fact that they're open source means they have a license. And some licenses could be risky from a legal perspective for organizations, especially if they're commercial enterprises. One of these components has a high-risk license, right? So we'll identify that as well. To give you an idea of how this works, let's look at one of these components. So for example, this second one here, this Swagger API UI library, it actually has a critical security vulnerability. And we're recommending here automatically what's the safer or safest version of this component to upgrade to. All right, so that's automatically making that recommendation. To see that kind of more visually, if I open up this specific component's timeline, I'll see the full version timeline, the history of this component. The version we're using, and this is a bit extreme, but it's from 5 years ago, so it has that critical vulnerability. But if I upgrade to a newer version, I'll see that vulnerability has been removed. All right, so that's just a simple example of how software composition works. And then similarly, you'll see the license risk here. So I could actually see where is, okay, so one of my components, this one UNorm actually is using a GNU GPL v2.0 license. What does that mean? Theoretically, and you would obviously need to consult with a legal expert, but this particular open source license, depending on how this component is used in your software, could legally require you to now open source the entire software system. That's a bit extreme, but it does happen and it could happen. So that's another reason why software composition is a very important part of planning any kind of modernization or migration. All right, and let's finish up finally in cloud ready. So we've been talking about this concept of cloud readiness. This application has a cloud ready score of 64.8. That's actually an average between some inputs through a survey, which you can see the survey questions and answers here, and the inputs through the source code scan. All right, so let's take a closer look at that scan to see what's happening. Basically, what the scanner is doing is it's looking through the source code of the application, looking for what we call blockers. These are patterns in the code that will make an application harder to or impossible to migrate and be cloud native. If we find one, we reduce the score. If we don't find it, we increase the score. We're also looking for things called boosters. These are more cloud-friendly coding practices. If we find one of those, that also increases the score. So an example of one is performing file manipulation. We talked about that briefly before. We found that. We found this happening in this application. We found it in the Java code. We do this by technologies. This app actually has a few different types of technology in it. So we found that in the Java code. Over here under this column roadblocks, this is a count of the individual occurrences of a blocker, right? So we found this perform file manipulation blocker. It occurred 157 times, so that's 157 roadblocks. If I click there, I'll see the location of where all of these roadblocks are occurring. We'll also estimate the effort that's going to be required. You can customize this effort calculation, but out of the box, we will estimate the effort to remove that blocker. And if you ever want to understand a little bit more about why this is an issue, if you click on this question mark here, this will bring up our knowledge base that gives you the full detail on why this is a blocker, what you should do, how we detect it, and additional documentation and references. In addition to these blocker patterns and giving you the location and the effort, basically, we're also making recommendations on what are the cloud-ready services, cloud native, I should say, services that this application is probably a good candidate to adopt. So we'll do that for AWS, Azure, Google Cloud, IBM, basically based on the technical characteristics and the types of functionality this application has. We are automatically detecting that and recommending different cloud native services from each of the cloud providers based on that information. If you're looking to containerize your application, we'll provide similar insights there. If you want it to be multi-cloud, we'll provide insights there. And then finally, we have a number of plugins to other systems for further using these types of insights and data. So for example, if you use Jira for issue tracking or management, we have a plugin that plugs directly into Jira. You could see we pulled for this application, the blockers here. You could assign them to teams for remediation. So for example, if I'm a team member that's working on this application, I might have, here's my to-do list that came out of the insights from Cast Highlight and then were pushed into Jira and then assigned to me as an application developer. So again, very quick overview and demonstration of the technology in action. Essentially, as a quick summary, we started at the portfolio level, used the insights to start building that roadmap, segmenting, and prioritizing application into different migration paths. Then we drill down into one application to understand any open source or third-party library dependencies that might have some risks, both security and legal. And then we looked at the cloud readiness. What are the blockers? Estimate the effort to remediate. What do I need to do? Get some recommendations on cloud native services that we could look at once we get to the cloud. And then I could push that information out into my project or ticketing system to start assigning those tasks to the team members. So just a quick summary of the product and the technology in action. And then just kind of finishing up, if you want to actually get a chance to try browsing, get a free try of browsing all those different dashboards that I was just showing and go as deep as you want, you can get a free trial here via this URL. And obviously feel free to drop me line or an email if you have any questions that I might be able to answer for you. So, but that kind of pretty much concludes the content and the demo. Definitely open to any questions that might come up.
Thank you very much. That's really interesting and impressive. I actually have a question that is about the way you are creating this bucket and adding application to this bucket. I saw that at some point there was one of the line was talking about business impact.
Mm-hmm.
Can you talk a little bit about how you collect this information and how they, for example, are like you want to retire? One, I was looking how you were defining also. So if you can give a little bit more.
Yeah, that's a great question, Gabrielle, because I did go through that pretty quickly. So just as a recap, the inputs to all of the dashboards that I demonstrated in Cast Highlight are coming from, one, the automated analysis of the source code, and two, a set of surveys that the application owners complete about each application. So in the case of business impact, we actually have our own out-of-the-box business impact survey that asks a few questions about the application. For example, how many users? Is it used with external clients, or is it just for internal use? Things of that nature, right? And then a business impact score is calculated based on the answers to those survey questions. And that's one of the factors or variables that's used in a model that's calculating or recommending should an application be re-architected or retired. So for example, let's say you have an application that has very low business impact and is not very cloud ready, et cetera, has a lot of health issues. The recommendation might be to retire that application because of those inputs. That's a very simple explanation, but the model is basically looking at those types of inputs. Now, we have clients that already have all of this data. They don't want to fill out another set of surveys on each of their applications because they have an enterprise architecture tool or some kind of CMDB or other inventory of their applications where that data already exists. You could simply import things like your business impact scores into Cast Highlight. You don't have to use our survey and our calculation. You could use your own if you already have that data.
Thank you.
Very cool. I was really impressed actually. Like I knew going into this that you were very deep into the whole like the analysis of applications and the quality and the you call them roadblocks, I think, and things to fix. I wasn't so much expecting the recommendations, the cloud recommendations in general, and also the integration with Jira, which seems very powerful to essentially take each one of those like the roadblocks and other issues that you identify, and you can automatically basically create a Jira ticket. I guess that's pretty powerful. Yeah, I guess it's not really a question, just
Oh, thanks. I mean, it's obviously a product that's been around for a few years, so have built a lot of extensions. We have pretty, what I hear is that we have a pretty awesome API, a REST API for the product. So we have a lot of clients that are actually doing their own extensions and integrations with the product into other tools that sometimes we're not even aware of. We have clients that have connected this data into things like, ServiceNow, LeanIX, Alphabet, you name it, right? So lots of other products and technologies that are managing applications, but don't necessarily have the technical data we can get by analyzing the source code. See a lot of value in pulling our data into those systems. So we see that happening quite a bit. And then obviously we had to work pretty closely with Microsoft, Amazon, Google, and IBM to build those recommendations into the product. That wasn't something we came up with on our own. We needed a lot of input from them for that. Interesting.
Yeah, really a deep level. It shows that there's a deep level of partnership. Yeah, as you're saying, that's going into this. It's a really rich in its feature, in its depth and its breadth, actually.
Cool.
Yeah. You had an applause there. Santos had to leave the Zoom, but it's
okay.
You got it.
Our one attendee gave us some claps. I love it. That's fantastic.
Yeah, it's exciting. Yeah, I can see why you're growing so quickly.
Cool, thank you.
So, yeah, so the access that you said is basically the same set of applications that you were showing,
Correct.
giving people the ability to spend some time kind of clicking through on their own and getting a feel for exactly what they could get out of it.
Exactly. So basically, by going in here and signing up, you would get access to instance that's pre-populated with a bunch of apps. So you could, you know, have fun going and checking everything out, and it's very quick. It's basically like already baked for you, so to speak, so that you could browse different types of dashboards and reports.
And
Mhm.
to make this properly work, so you install this in the customer environment, I guess, and it's connecting with their Git repository, and then.
Yep. So that's a great question, Gabby. There's different options we have for deployment, depending on how clients are managing their source code. But if you're just, you know, doing a quick one app, you know, analysis, we have a very nice graphical user interface analyzer you install on the desktop, and you just point it at the source code folders and it'll do the analysis. If you're analyzing an entire portfolio, multiple applications, we have plugins for things like GitHub Bitbucket that will automatically plug in and do that. Or we have basically a command line interface for essentially scripting it to plug into and automatically analyze theoretically code living in any kind of repository. But once the client sets that up, and we have a services team that would help them do that when they're deploying Cast Highlight for the first time, after that, it's all automated from that point forward.
And I'm also, no, you go, Cora.
No, go first.
I'm interested in understanding, let's say that, of course, with the partnership that you have, I'm sure that all of the recipe and like you are pretty aware and well equipped to respond properly in providing a recipe to fix something that is not exactly right. But can also the customer add its own? Let's say that there are situations where I don't know, I'd like to implement in this way instead. Is that something that can be enhanced in this code base of recipe?
So when you talk about doing it their way, just so I'm clear, Gabby, are you talking about like specific things that I showed, like, for example, the model that recommends whether to rehost, refactor, re-architect?
No,
or are you talking about the specific coding?
Exactly, the last one.
Okay, got it. So there's a few things you can do there. First off, if there is some kind of code insight that's not pre-built into the product, we actually have a feature of the product called a keyword analyzer, where you can design your own patterns to go looking through the code for, right? You basically customize, you design the strings, the characters, the text, basically uses regular expressions, and that's used for various purposes. One of the common use cases for that is for clients that are trying to understand if they have applications that are manipulating sensitive or personally identifiable information data, you know, for GDPR compliance and things of that nature. They will actually configure that analyzer to look for things like, you know, do we actually have applications that are doing things they shouldn't be doing directly in the source code, like storing you know, addresses or phone numbers or things of that nature. So that's one use case for that analyzer, but it could be used for essentially looking for any kind of pattern in code. So that's one thing. And then we're regularly adding new patterns that are built into the technology. So we get feedback from clients and partners all the time on a pretty regular basis, and it doesn't take too long for us to add new. If it's a pattern that would benefit everyone, that's kind of universal, it doesn't take too long for us to add new patterns directly built into the product.
Oh, okay, so the catalog of recipe that you are providing is built on top of the community that it's using it, so everyone will benefit from everyone else that has been using.
And it's growing all the time. We're adding new patterns, we're adding new technologies. So we support over 50 technologies and programming languages today, and we're adding probably 2 or 3 every year new technologies to the product.
Nice.
I wanted to, I apologize if you already went over this, but I was briefly interrupted, so I don't know if I just missed it, but, so I saw a lot of like the analysis and the exposing of the problems and the possibilities and, and the creating of the JIRA, but, do you have the ability to automatically fix source code as well?
Good question. So that's the one thing that we don't do. I shouldn't say the one thing, but that is something that we do not do. We don't modify code because we don't actually have access to the source code when you're browsing it. The only time the source code is accessed is when that analyzer is running locally. But that's not something that's in our, kind of our product strategy, is to actually modify the code of applications. There's some other tools out there that are starting to tackle that, but we don't think the technology is quite there yet to confidently modify the source code of applications for big, massive, complex systems that are typically what this product's used for, right?
So many different languages.
Yeah, exactly.
Makes sense. Cool. Well, I thought that was amazing.
Great.
Yeah.
Thanks for the good questions. That was really good.
So yeah, and Gabby, do you have anything that you want
No,
to add?
I really appreciate also the initial video that set the stage pretty
Yeah.
well, I think.
Yeah,
Cool.
so
Good.
fun. So yeah, great. Thank you for being one of our guest speakers, our special guest of the day. We really appreciate it, and we are glad to see this incredible software and to help get the word out.
Awesome. Thank you so much for having us. Really appreciate it. And have a good rest of your day and evening.
Thank you.
See
You too.
Bye now.
Bye-bye.
Bye.